Okay, so I'm gonna start by talking about a couple of ways that you can add voice to a mobile application, and then I'm going to spend a little time about talking about ASR and TTS on the Android and iOS platforms, and conclude by then going to talk about a couple of things that we need to keep in mind when adding mobile to a voice user interface, and then the conclusion. So, so let's say that if you want to add voice to a mobile application, there are a couple of ways that you can do that. And Jonathan was talking about a couple of those approaches. So one of the easiest things to do is to use TTS, which stands for text-to-speech. So if you have some text areas in a mobile application, you can put SDK to read some of those text areas. Also, you can use ASR, which stands for automated speech recognition. So the way that the ASR engines work is they have a grammar that is associated with certain keywords, and you basically speak to the mobile application, and then it takes in the voice file, and then it sends it to the ASR engine, and then it tries to figure out what you said based on the grammar with a confidence level. So for example, let's say that the question that the mobile application is posing is what kind of pizza topping you want. Then the user would say something like pepperoni, and then the grammar at this point would be the different pizza toppings like pepperoni, mushroom, pineapple, and let's say vegetarian. And the ASR engine would basically look at this grammar and then what you said and put a confidence interval to the particular grammar. So it would say, since you said pepperoni, it would say with the confidence level for the pepperoni is, let's say, 85%. And in the mobile application, you will have a particular threshold above which you accept a positive response. So let's say that the threshold is 80%, and if the ASR engine is telling that with 85%, it can tell that you said pepperoni, you would accept it as a positive response. So that's how the ASR engines work. Then you also can include the hands-free triggers. So for example, if your application is to get speech input, you can't have the application constantly listening, right? Because it's memory, it's resource intensive, and there could be background noise going on, and the application might get confused. So there should be a point at which the application should start to listen. So speech hands-free triggers is a way that you actually tell a specific keyword that the application knows, and when the application hears that particular keyword, it comes out of the sleep mode and it starts to listen. So those are hands-free triggers. And you can also have audio clips that you have recorded, voice clips that you have recorded that you can play at different points in the application. You can even get the application to make and receive phone calls. So for example, at Angel, we have a mobile application where it checks the number of agents that are currently available to get your call. And if you don't want, if there are no agents available, you can click on a button, and the agent will actually call you back at a specific time. So those are a couple of approaches. So I want to spend a little time on ASR and TTS in the Android and iPhone platforms. So Android, the operating system, has had ASR, automatic speech recognition, and TTS capabilities almost from the beginning of the platform, since Android 1.5 and 1.6. So if you want to use TTS in the Android applications, it's pretty straightforward. You have your text string, and you send it to the TTS API, and it speaks it out. The operating system speaks it out. So you can control things like how fast it talks. You can control the pitch of the sound, so you can fine tune it. And it works in the cloud, and it's free. And if you want to do speech recognition in the Android platform, it also comes in the platform out of the box. And there's a recognition intent. So if you guys are familiar with Android programming, you basically call this particular intent. And once you do that, it brings up a UI telling that it's actually listening. And then it records the voice file, and it sends it to the Google Cloud, and it recognizes it, and your application gets back a list of text in terms of what it thinks you said. So let's say that you said something, and then you will get back a list of text. Let's say you get 10, and it will be from what it thinks is the most accurate in terms of what you said to least accurate. So you can select, maybe I'm going to select the first 3 in terms of the responses. And then of course there are third-party APIs. So Jonathan mentioned a couple of third-party APIs. So there's also one, in addition to what Jonathan mentioned, called iSpeech that can be used for TTS and ASR. And Nuance is of course a big player, both in ASR and TTS. And if you want to add voice capabilities on the iPhone platform, there is nothing that you get out of the box in terms of the native platform. So you have to use third-party APIs. And there are more third-party APIs for iPhone than Android. So if you are going to add TTS to your mobile application, these are a couple of things that you should keep in mind. You should have a way to interrupt when the application is talking to you. Because sometimes you may know what it's telling, and you can even see what it's telling. So you should be able to interrupt and then go along with whatever you want to do next. You don't want it to actually wait until it completes everything that it's saying. You should also spend some time to fine-tune the speed and the pitch of how it talks, because it makes a very big difference in terms of the user experience. And if you are doing TTS, obviously don't be selective in terms of what you want the application to speak back. So don't try to use TTS for entire large blocks of text, because it can be annoying. Unless, of course, you are doing something like an e-reader, where you want the application to read the entire book. And as Jonathan was mentioning earlier, most of these APIs actually work on the cloud. So you should consider how the application works when there's no internet connectivity. So if there's no internet connectivity and the application can't talk, and then you're using TTS, you should have a mechanism to deal with that. So these are a couple of things that we should keep in mind if we're adding speech recognition to a mobile app. So it's important to guide the user in terms of what responses we're expecting, because the ASR engine has the smaller the grammar that you have in terms of recognizing what the user said, the more accurate it's going to be in terms of recognition. So for the user, to get the user to tell something specific, you should try to guide the user. So maybe you should post a question. Going back to my previous example, telling like what kind of, if it's a pizza ordering application, what kind of topping do you want? So obviously the user knows that you have to tell the different toppings instead of like posing more vague questions. So try to confine what the user can say, because the recognition will be better. Consider the user environment, and based on the use case of the application, if it is being used a lot in very noisy environments, maybe speech recognition is not a good idea. Or maybe you want to have speech recognition as a second mode of input and not the main mode of input. Consider no match and no input. So no match is when you say something and then the application doesn't recognize what you said. So what do you do at that point? Do you say something like, sorry, I didn't understand it, can you please see it again? Or do you bring up a GUI widget and tell, can you please touch and provide the input? So you have to think about that. And what happens if there are continuing no matches? So you say something, it says, sorry, I didn't understand that. You say it again, you say, sorry, I didn't understand it. So are you going to continue this loop, or are you going to do something about it? So you have to consider that. So no input is if the application is waiting for voice input and the user doesn't say anything. So you have to think about that. Like for example, how long are you going to wait for the user input? Are you going to wait for 10 seconds? And then consider that, are you going to listen for 10 seconds? And consider that to be a no input. And what are you going to do if you happen to get subsequent repetitive no inputs? And I think you should always be able to use the graphical user interface for everything that you are planning to get by voice input, because it could be that you want to use the application in an environment that you don't want to speak. Maybe like it's at a meeting, or maybe it's in a very noisy environment outdoors, and speech recognition is not working at all. So you should be able to use the graphical user interface and not rely only on voice input. And then, like I was telling earlier, if you're using voice input, the application can't continue to listen to you all the time because it's memory intensive and so forth. So when does the application start to listen? Are you going to have like a big button like in Siri? When you click on it, it starts to listen. Or are you going to have something like voice triggers, where it sort of like listen to only specific trigger keywords, and when you say those trigger keywords, it actually starts to listen to the full grammar. So these are a couple of applications that we have done at Angel in terms of trying to add voice for mobile applications. So on the top left, you see voice for Facebook, which is our attempt to adding voice to a Facebook application. So you can do voice post to Facebook, and also you can get it to read your Facebook wall. Slide Shout is also an application that works on Facebook, but is focusing on photos. Because we found out that photos is one of the areas where there's a lot of interaction in Facebook. People like to see a lot of photos and then do comments around photos. So we wanted to create an application that focuses only on photos on Facebook, and then provide the ability for people to voice comments on photos. So that's Slide Shout. So voice for Twitter is a way that you can use voice to provide tweets. And you can do voice tweets. You can't actually read back your Twitter feed at the moment, but you can do voice tweets. And one of the features of this application is you can actually embed voice and writing in the same tweet. So maybe you can start with, I'm at this exciting party, and this is how it sounds, and then you can start recording the atmosphere, and then you can tweet it. So which is very interesting, because you can't convey that same emotion and excitement by writing, right? So voice for Twitter voice channel is the application. It works on Twitter, but the way it works is we have a number that we publish, so that anyone can call this particular phone number, and then they can keep a voice tweet, and it appears in Twitter. So you don't actually have to have the Twitter application or a Twitter client to keep a voice tweet inside of Twitter. So voice for Facebook is similar. There's a phone number, and you call it, and you can do voice posts inside of Facebook. Voice for Chatter is a Salesforce application. It's kind of similar to Twitter, as in it's sort of like a Twitter-like environment, but it runs inside of Salesforce, and it's a controlled environment in terms of who can see it. And so voice for Twitter is a way for you to do voice tweets inside of the Chatter application inside of Salesforce. So the conclusion is that Siri has made voice interaction in the mobile space more prevalent among the mainstream. I mean, still obviously it's not something that you see being used a lot, but since Apple has did a lot of marketing around Siri, I mean, more people are talking about it. And then smartphones obviously are becoming more powerful, and then the TTS and ASR capabilities on smartphones are becoming better. So those capabilities are now there to build good voice applications. And obviously phones are becoming smaller, more powerful. People are trying to do more complex things on the small devices, and most people are trying to do these things on the go. So voice is becoming more and more interesting in terms of both input and output mode for mobile devices. So that's it. Thanks. Go ahead.
Could you describe, I'm just curious, a long time ago, did some computational linguistics research.
Right.
And edited a lot of grammars.
Okay, right.
And I knew some folks that were doing the hierarchical, you dial in and you say, click 1 or click 2.
Right, right.
Could you describe a little bit about the effort and the characteristics of I guess you'd call them maybe conversation grammar editors? I presume that there's some kind of graphical environment in which you can lay out the sort of the domain, the routes, like, okay, this happens, then this happens, and this happens.
Right.
And that is then somehow, I don't know, turned into machine readable or Can you tell them a little bit about that development process from the point of view of kind of domain experts? Someone who understands the conversations that would happen in that domain.
Right. Now, so one of the things that we also are building a voice assistant in-house. And for that particular assistant, we are using what we call a state machine. And that particular state machine actually determines the flow of what happens in terms of whether you get a positive response or a negative response in a particular state. So that state machine actually doesn't have anything directly related to a particular grammar. It's just a way to identify the state in terms of the flow of the particular interaction. So at least in the Android application, we have been using this language called SCXML, state chart markup language, that helps you to define the state. And it's a W3C, it's not that, it's a W3C program that's actually creating this particular language. And that's the official way where you would actually define the flow of these interactions.
That was state chart markup language?
Yeah, SCML. Just Google SCML.
One quick question. You talk about voices for Facebook.
Yeah.
And it looks like it was for the iPhone. I see it's in
Yes,
the
yes.
But the iPhone for Facebook has the microphone, so anything that has the text input at any point, you can hit the text or doing it.
Yeah.
What's the advantage of having it written like you did
Yeah.
directly for it, as opposed to having it part of a fairly good user
Yeah.
interface?
Right. So the voice for the Facebook application, when you click on that microphone and when you speak, it actually transcribes it, and then you get text back.
Right.
And what you're actually posting on Facebook is the text.
Right.
But what we do is we actually record your voice, and we actually upload the sound file.
No, I thought it was doing voice recognition. So what you're doing for voice is actually recording the voice.
Yes.
So yes, that's different.
Right,
Okay.
right. Got it. Go ahead.
Do you have any comment about the Google APIs that are supposed to be coming out soon?
Google APIs they're already out, right? I mean,
Yeah, it says Siri.
yeah, so Mergel, right? So I mean, it's sort of like there's nothing official from Android in terms of this particular voice application, but my understanding is going to be a different from Siri. So Siri is sort of, it's trying to be conversational, right? So when you interact with Siri, what they're trying to do is they're trying to make it as if you're speaking to another person, right? You can tell jokes, right? It can do jokes back to you. You can ask like, what's your name? Like stupid questions, and it will give back stupid answers. But Major, like, Major, as opposed to that, the concept is they want to make it as if you're speaking to a computer, right? They want to take the approach that when you're speaking to a computer, you know that you're speaking to a computer. And we don't want to simulate as if you're speaking to another human. So it will be like in Star Trek, right? You say like, computer, what is the, send me, locate this particular file. And then it will basically speak back to you. So the approach is that it's not going to be funny. It's not going to be like conversation. It's going to be as if you're speaking to a computer. So it's going to be a different approach. Yeah, but there's nothing official. Okay, thanks.